Well, welcome to this online revision session for AQA FP3. We're looking at the June 2011 question 1 on the numerical solution of differential equations. As you can see in this particular question, the method that we're being expected to use is the improved Euler formula, and the formula itself is defined not just in the formula booklet but is given in the question, as is usually the case. And in this particular case we're starting with x as 2 and y as 1, and we have a step length of 0.2 for h, and we're being asked to find the y value for when x is 2.2. So we're only doing one iteration in order to obtain the answer we require. Okay, so working through this then, we can see that in order to work this out we need to find the value of k1 first, then find the value of k2, and then we can find our new value of y from the y value that we've got as our starting point. So we know initially that x0 is equal to 2 and y0 is equal to 1 from the line given above. So in order to calculate k1, we know it's supposed to be h, which is given as 0.2, multiplied by the value of the gradient function f, and that gradient function is found by working out x plus ln of 1 plus y. So x is 2 plus ln of 1 plus the y value, which is also 1. And so we can then just put that through our calculator and work out that the value of k is 0.5386, and we need really more than 4 decimal places if we're going to get a final answer that's accurate to 4 decimal places. So I personally would write down at least the next 2 figures. But whatever happens, use that value in the next part of the calculation wherever possible. So in order to calculate k2, we know it's given by h times the gradient function at our new coordinate. So h is 0.2, and again our gradient function is given by x plus ln 1 plus y. So x at the new point, x1, is 2.2 plus our y value, which will be ln of 1 plus the y value, which is going to be 1 plus k1. So this becomes 1 plus k1, which is 1.153869. So that's where we would need to use the value on our calculator that we've got from the previous. And so again, working through that calculation on our calculator, using the value from the calculator previously, we end up with an answer of 0.626, and then we get 242 coming on the end of that. Okay, so we got our values of k1 and k2. So now we can work out our new value of y at x equals 2.2. So our new value of y when x is 2.2 will be given by, well, the formula is the previous value of y, which was 2, plus an average of k1, which was the value 0.538629, plus the value of K2, which is 0.6263248. And once again, we put that through our calculator, and we will end up with a result of 1.582477, and the answer we actually require is to give the answer to 4 decimal places, so rounding it off we get 1.582, and that will round up to a 5, and that's your 4 dPs. Just got to be very careful working with your calculator through this question. So working out K1 will give you 1 mark. Working through the K2 you get 1 mark plus an accuracy mark for obtaining the correct value of K2. Having got that, you then, for working out y when x is 2.2, get a method mark for showing the correct calculation to be done, and then finally an accuracy mark for obtaining the result to the required number of decimal places. Hopefully you found that solution helpful. For more examples and for further work to help you with your revision, please go to the Further Maths Support Programme website.